Okay, class, now we're going to move on to page 2. Again, key ideas about physical and chemical changes are found in the top, and the questions are below. Now, looking at the first question, it asks which process is a chemical change. When we see the word chemical change, we always know that a chemical change is going to involve a breaking or a forming of a bond. So here we have melting of ice. That's a phase change. It's not a chemical change. So it's not A. We have a corrosion of copper, which is a chemical change. So this is the best choice. And then when we look at the other choices, evaporation of water, again a phase change. And crystallization. Crystallization is a fancy word for freezing of sugar. Again, not a chemical change. That's a phase change. Next, we're looking for physical property. Remember that physical properties do not change the identity of a substance, and they are usually observed with the 5 senses. So looking at the descriptions, you can see react. React always goes with chemical change. Again, we have react, and then we have form a compound, which is form a bond. If you form a bond, you're making a chemical. That is a chemical change. Then lastly is form an aqueous solution, which means dissolving in water. So that would be choice D. If you dissolve something in water, it still maintains its identity. For instance, if you put salt in water, you have salty water. The next question, we're looking for a physical change. Again, a chemical change makes bonds. So a physical change will not make any new bonds. We'll have no new substances. Now, new substances will have different chemical formulas. So in the first equation, to the left of the arrow we have water, and to the right of the arrow we have water. So this is a phase change or physical change. Now if we look at the other examples, we see that in choice B, to the left we have hydrogen and oxygen, and then to the right we have water. We formed a bond, so that's chemical. Again in C, hydrogen and iodine form a bond to make hydrogen iodide. And in D, nitrogen and oxygen also form a bond. So A is the best choice. In question 9, we are basically asked to describe the type of change and the chemical properties of the products and the reactants. So when we're looking at the picture, we see that here we have elements and they bond together to form a compound. So this is a chemical change because we're forming or breaking bonds. So we can immediately eliminate the first 2 choices. And we know that in a chemical change, the properties of the substance always change. So choice C is the best answer. At the top of the next page, we'll have some key information here at the top, and then we'll have the questions below. Let's take a second to look at the questions. The first question asks us which represents a compound. Remember that compounds are substances that are formed when 2 elements are bonded together. So compounds must have at least 2 different elements or 2 different capital letters in their formula. So choice A only has 1 capital letter. So that's not applicable. Choice B only has 1 capital letter. Choice C has 2 capital letters. And choice D only has 1 capital letter. So choice C is the best choice. The next question asks us how to separate a mixture of salt and water. So we should understand that salt completely dissolves when you mix it with water. That forms an aqueous solution. Aqueous solutions can never be separated by filtering. So the other choices that we have are evaporation, paper chromatography, and density determination. Now, because there are not 2 distinct density layers in a salt-water mixture, that would not be a very good separation technique. Paper chromatography, often used to separate components of a dye mixture, have to separate components that would have different bonding to media or different solubility within media. So this is again not the best choice. And evaporation is a common way in which we can extract salt from a saltwater solution. The next question asks us, what is a mixture of substances? So we have to have more than one thing. Now, when we're first given solid, liquid, and gas, those are just phases of matter. They do not indicate two different substances, but solution indicates two substances, typically a substance dissolved in water. In question 13, they're asked why distillation is an effective means of separating the components of rubbing alcohol and water. So we recall that distillation is a separation technique that is related to boiling. And whenever we separate mixtures, because they're not bonded together, we're always physically separating them because mixtures are not bonded. So choice A and B are not good choices because they talk about chemical separation, which would require a chemical reaction. So now we're forced to choose between choice C and D, and the best choice is going to be choice C, because if we want to separate a mixture based on boiling point, they need to have different mixtures. If they had identical boiling points, we would not be able to distinguish the two parts. In question 14, we're looking for a substance that can be decomposed by a chemical change. Remember, chemical changes require making or breaking bonds, so we need to find a substance that's bonded together. Recall that two elements bonded together, or two or more elements bonded together, are called a compound. So substances that are elements have symbols with only one capital letter. So that automatically eliminates choice A, choice C, and choice D. Choice B is the best answer because it has two or more capital letters, meaning it has two or more different elements bonded together. Question 15 asks about elements. Now, here, this is a pure definition type of question. Recall that elements of all atoms of a given element must have the same atomic number, which is the same as the number of protons. Protons inside the nucleus of an atom are what give an element its identity. So an element of oxygen will have 8 protons, while an element of nitrogen has 7. Again, protons, the atomic number, are the identifier of different elements. The information in question 16 will be tested on Unit 1, Test 2. For Unit 1, Test 3, you will still be tested on your ability to determine significant digits and use proper measurement technique. Question number 17 asks, which number contains 4 significant digits? When I examine significant digits, I use the Atlantic and Pacific rule. If the decimal is absent, you approach the number from the right side, the Atlantic Ocean side of the number. Hit the first non-zero digit and count the rest. So question number C has 4 significant digits. Let's look at the significant digits and the rest of the numbers. Choice D, again, has no decimal point. We approach from the right side of the number. We wait until we hit a non-zero digit. That would be a 7. That remains 3 significant digits. In choices A and B, we're going to use the Pacific rule. A decimal is present, so we approach the number from the left side, or the Pacific Ocean side of the number. Hit the first non-zero digit. So choice A, the first non-zero digit is an 8. Choice A only has 2 significant digits. And choice B, again, we approach from the left, hit the first non-zero digit, and count the rest, has 3. So again, the best choice here is choice C. Lastly, we are asked to measure a volume that is pictured in this thermometer. Now, recall that you'll have to look and see what each tick is. So examining our thermometer, we'll see that the major ticks are 10 and the minor ticks are 1. So if I was giving this measurement, I know that this major tick here is 0. So it appears to be at approximately 4 degrees. But all measurements must include all of the ticks that you see plus one estimated digit. So here the best answer is going to be 4.3. Again, you have to include all the ticks you see plus an estimated digit. Question number 19 will not be tested on Unit Test 1. You'll see that on Unit Test 2.